On February 11th. All right, let's do this. Majority event. It's an easy question. Given an array, return the majority event. The majority event is the event that appears more than n divided by 2 times. So you may assume that majority event always exists in the array. Should you solve the problem in linear time in O1 space? O1 space. Which means we cannot use a counter. Isn't that the voting, right? Is this the voting algorithm, right? I forgot. How do we do the voting algorithm? The voting algorithm is as we keep going. Now when we record the current, whenever we find, wait, hold on. How do we do the voting algorithm? Yeah, this is voting algorithm. I forgot. Voting algorithm is I'm gonna check. I forgot how to do a voting algorithm. What's the voting algorithm? Boy Moore, majority voting. Yeah, that's the one. If an element is more than n divided by 2 times, it means that the remaining elements other than this would definitely be less than n divided by 2. So let us check the preceding. Choose a candidate from the given set of elements. If it is the same as a candidate, increase the vote. Otherwise, decrease the vote. If votes become 0, select another new element as the new candidate. So which means it will increase if it's the same, it will decrease if it's different. If you select is the actual thing, then you will have more increase and decrease. So eventually you will have a positive value, right? And if you have something that's wrong, then something else, the actual one will overwhelm. Yep. Where decrease the priority of winning ability of the selectors. So we know that if the candidate is a majority, occurs more than n divided by 2 times, from elements and less, then we keep decreasing the votes since we found some different elements. Yep, that's the voting. Yep, we use voting can. So if it's the same, I increment. If it's not the same, I decrement. And whichever is left is going to be our result. So we're going to have 2 variables, a candidate and a count. Actually not count. Candidate and vote. Candidate and vote. Okay, so let's do, we can do Java on this one. I think yesterday it should be 12. Oh. use the voting with a Boyer-Moore, right? Voting algorithm. Boyer, M-O-O-R-E, yeah, Boyer-Moore. Int candidate. Okay, int vote for I smaller than nums.length plus if nums I not equal to candidate. Actually, we can do this. Vote plus equal to nums I is equal to candidate. Equal to is 1, otherwise minus 1. If vote is equal to 0, candidate equals to nums y. And then I return candidate. Do I have to do this? Interesting. Is it not right? Or shall we start from 0? Yeah, there should be 1 vote, 0 vote, I switch to 2, right? And then next one is vote right now becomes 0. So this one has 0 vote. Shall we add a 1? No, I think when vote is 0, it just means we're gonna swap to a new thing. And then I need to have a new vote. I think that is necessary. Reset vote to 1. Yeah, to reset the vote. Okay, that's not really what we're interested in. Actually, let me take a look at previous. Yeah, we have this. Alright, this is the most important, interesting thing. So we're gonna go back to what we tried yesterday, which is we're gonna do a DP to do this. Okay, we're gonna do a DP to do this. And we're gonna go top down for this. All right. So we definitely need func tools. Okay. Then what we need is when define def dp, right? dp we say what we need is the starting st start and then num digit. Okay, and we're gonna return an integer. So we'll start with something and then say num digit. We then say if num digit is equal to 1, then return 1. Right? So if we'll have 1, actually I need to also do this. So what we're gonna say is dpst num digit returns the number of stepping numbers starting with digit st and having num digits number of digits. Yeah, let's do digits. Okay, so this is s, right? If we have 1 digit, then it's just by itself. Okay, and of course it actually depends, right? Because we cannot have 0. There's no leading 0. There's no leading 0. Okay, there's no leading 0, which means we just need to be careful, right? We just need to be careful when we do the actual thing. We should avoid leading zeros. Because we can have leading 1, then we have leading 0 with however many, and then they all count. So it should be fine. Okay. Then what we say is given the current st, right? Given the current st, we +1, -1, and then yeah, we shall return dp st +1, but 9 doesn't have +1, right? So we say if st is equal to 9, we shall just return dp 8 num digits -1, right? Because if it starts with 9, we cannot +1, so we can only do -1. If st is equal to 0, I should return dp1 num digits -1. Otherwise, we shall return dp st +1 num digits -1 plus dp st -1 num digits -1. So that is dp. Can probably also do this at value cache. Right, so LU cache this. Then we can say we have low and high. Okay, so we have low, we can get its first when we know its number of digits, right? And then we handle that by, as I have this, I know the number of digits, right? Then we basically just see the second. We just need to check the second, right? We check the second. But what if the second is the same? Ooh. Like we start from some value and then we're gonna go check the second, right? We're gonna see if the second is because we start from something and the second digits we can do whatever it is, right? And then if it's, because we handle low, right? We handle low. And then we handle high. handle low, handle high. How do we handle low? We know the number of digits, right? And then we just say, maybe we can do a kind of a DFS type of thing. You know, like a DFS type of thing. We say there's a start is 9, right? First digit. And then we go for the second digit. And then we say it's equal, then we go for the third digit. Digit by digit, right? Digit by digit. If we have some digit is bigger, then we can just end. So maybe we can do this. Q equal to low 0 int low 0. Okay. And then while Q for D in Q, right? D in Q. If, and then we also have index is 0, right? Okay, then we say if D is equal to low index int if it's equal to, then temp dot append d minus 1 depends, right? If D is larger than 0, and then if D is smaller than 9, right? If D is larger than int low index, right? So the current is bigger, then I'm gonna say count low, then count low plus equal to dp. So current D, so we say D. What's the number of, well, it's gonna be len low minus index minus 1, right? Because we have the current is larger than this, which is what we want, right? It's larger than, and then number of digits is gonna be the total number minus the index. So index is 0, so we do index plus 1. Okay, so that's that. Else is current is smaller, then we cannot do, so we don't even do this else, right? And then we do Q equals temp, right? We grab the temp, go back, and then we try until we get to the end. So there should be an end. End is when index run out, right? So it should be this, and index is smaller than len low, right? Index is smaller than len low. So by doing this, we basically the only time is if it's equal, right? If it's equal, we'll go to the next one, and we'll go to the next one. We might still be equal, but the other one will not be equal, and the other one probably is either bigger or smaller. They will all be done. If it's equal, then we just keep going, keep going, keep going until, what if it's all the same? All the same. Then when we get out, if there's something in the queue, then that is something we need to count as well, right? So we say once I get out, if queue, then count low plus equal to len queue. Whatever is in the queue, these are also available. So this is to count queue, to count low. And then we have to count high, right? We need to count high. Which is essentially the same, right? Essentially the same. We just change line, we just change this, we just change this line. Everything else is the same. So maybe we're gonna write another function. Def count count low or high, count and edge case, edge case, edge, and then is low. Okay, so count edge case. So edge is either the str version of low or high. So this is going to be edge, right? Index count. We don't do count low, we just say count, right? Q index smaller than this is edge. That's all good. Okay, here is going to be interesting. So what we can do for D current, we say int edge index. Okay, and then this one delete should be current, and then here we shall say elif is low and D is larger than current. Okay, or not is low and D smaller than current. When these happen, then we say count plus equal to dp D, which is a current digit, right? Because this is what we're gonna do. The current digit is either larger than the current digit or it's smaller than the current digit, right? So we say the D and then len edge minus index minus 1. Yeah. And once we're done, we do this index into plus equal 1. Index plus equal 1. Then we go to the next one, and then once we're done, we do this, and then we will return count. Okay. So rest will equal to count edge case low true plus count edge case high false, right? Then we need to count in between, right? Count in between. So that's basically we need to know the length, right? The length. Then we say for num digit in range len low, okay. Ooh, and also len low is 2 digits, right? So we need to add more. Ugh. say then count the rest of the stepping numbers with the same number of digits as low. Okay, then we say for st in range int low plus 1. Okay, int low plus 1 all the way to 9. Well, to 10, because it cannot reach there. Unless, well, it should be if int low is smaller than 9. Right, if it's smaller than 9, then we can do it. Do this all the way to here. And then we say rest plus equal to dp st. And num digits is len low. Okay. Then count the rest of the stepping numbers with the same number of digits as high. Again, if int, hold on, 0. Right, if int high 0, because we're getting -1, is larger than 1. Right, it's larger than 1, because if it's 9, I cannot plus 1. If it's 1, I cannot -1. Right, so I can do, okay, then we say for st in range int high 0 -1 all the way to, cannot be 0, so it will be like this, right? Then rest plus equal to dp st and then len high, right? Then we say count the stepping numbers in between. Okay. Then will be for num digits in range len low plus 1. Okay, all the way to len high. Yes, because then -1, because we already count with the same number of digits. And for them, and for each of 1, we need to go for st in range, go from 1 to 9. Then we say rest plus equal to dp st num digits. And return rest mod 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so this is the solution I have. Let's take a look. That makes sense. Ooh. Why? I have digit equal to 1. What happened? Ooh. So we start with 1, count edge case 1, and true. So edge is either this function returns the count of stepping numbers with the same starting digit and same length as edge. So we do, so Q is start with 1, index 0, count is 0, and then we do Q. This is true, temp, so Q is 1. Current is 1, right? Start 1, current 1, if it's equal. 1 is larger equal to 0, so temp, I tried add a, hold a second. We only have 1. Right? Like, try to compare the first. It's good, so temp I append the next, and temp dot append the next. So I append 0, and I can do 1, 0, 1, 2, right? And if it's low, yes, and D, no, then we get out. Oh, this is actually not right. Shoot. Yeah, they are the same, so we try to get the next one, but there's no next one, right? So we try to append, but that's if we have a next one, but now we don't have a next one, so we don't append, right? We don't append, and Q is end. Then we're missing, right? Then we're missing 1. We're missing 1 by itself. Hold on, I'm gonna change this. So if D is equal to current and index plus 1 is smaller than len edge, then we do this. And this shall be, if I go to the end, index if it's equal to len edge, count shall plus equal 1. And then here I shall say if num digits smaller or equal to 0, turn 0. Okay. Ugh. All right, that's an easy one. 51, 54. Let's get even easier. How about just 1, 2, 3? Okay, that's good. Let's take a look here. 1, 2. This should be 1, 2, 3. Low, high. Expected 19. Okay. Oh. Let's see. Okay, unprint. Edge case low, true. And count edge case high, false. Right, so we get these. And print result. Print result. Print result. Of course, we know. Prints it off for this at the end. Hold on. Maybe I have a better way. How about we print the result here? But in addition, we also do st, right? And here's the same thing. st. And then here we can print st num digit res. All right, so that's probably we get everything. So we start from 1, 2, and a 1, 2, 3. Okay. We have 1, 2, and a 1, 2, 3. All right, so we have 1. Starting from 1, that's 1. Yeah, just 1, 2. There's also 1 because either go 2 or we go 0. Oh, I have 2, right? That's 2. So you have this actually is 1, 2. This I can go 1, 2, 3, and then 1, 0, 1. Right, I have 2. Next, we shall start from 2. Wait, hold on. What was the thing I was talking about? We start from 2, right? We start from 2. I have, 2, 3, 2, 1. 3, 2, 3, 4, 3, 2. 4, 5, 4, 3, 5, 6, 5, 4, 6, 7, 6, 5, 7, 8, 7, 6, 8, 9, 8, 7, 9, 8, right? So after I handle stepping number, same number of digits as low, right? Then we shall have all this. And now here, the same digit has to be nothing, right? Then we have nothing on the other side. I have 2, 3, 4, 5, 6, 7, 8, 9, 18. Right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, hold on. So 1, 2, 3, 4, 5, 6, 7, 14, 15, 16, 17, 18. I'm missing one. I'm missing one. Which one am I missing? 1, 2, 3. In between. There's nothing in between. Who am I missing in between? Hmm. One zero. You're missing 1, 0. How am I missing 1, 0? Count edge case. So we're starting from 1. Okay, 1 comes in. It's equal. Then, because it's 1, 1 is larger than 0. And index plus 1. Ooh, index plus 1. Yeah, index is 0, right? Index plus 1 is 1. So it's good. So if d is larger than 0, d is 1. 1 is larger than 0. So I do 1 minus 1. So we should put a 0 in. And temp, second, we should put still have a 0, and then that's perfect, right? Index plus equal 1. Come to the next one. Then we have, oh, but 1, 0, yeah, 1, 0 doesn't work. 1, 0 is small, smaller than 1, 2. I cannot do 1, 0. Then where did we, where are we short? Oh, 1, 2, 1. Here's what we short. 1, 2, 1. We short 1, 2, 1. Yeah, we short 1, 2, 1. Which means we are at 2. Right? We're at 2, and there's still 2 is the same. So plus 1 is still smaller, so I push. Now I have 1. Right? And then we have 3. Okay? So the next one, 1 comes out, and 1 is, current is 3, so it's this. Right? And now we do 1. This is 3. 3 minus 1 minus, no, 3 minus 2 as a 0. Ooh, I think the problem is, what do we do when num digit? Huh. Number digit is 1. Yes, num digit, if they have no num digits, that shall also be a 0. So we start with something, but we don't have any left. Yeah, that shall also be. Okay, so I think we don't do this, but we say small or equal to 1. Small or equal to 1. So num digit is 0. Num digit of 1 is just, you know, Ah, well, we can do number digits 1, right? And then I can still do +1, -1. Ah, yeah. Yeah, okay. Okay, let's try one more time. GCC, and then we'll comment on this, comment on this. I think one more to comment out. Alright, try one more time. This one will be right. Okay, let's this. How about 1, 2, 3, 4? Ugh, dear me. That's why it's hard. These edge cases. Ugh. Okay, that's fine. Number 2, 3, 4. Is that right? Oh. I don't want to go to New York. We're not going to New York. Okay, let's do this one more time. And we probably, okay, let me do this way. And let me do this way. I paste here. Okay, I cancel this. What I want is to print. Don't print res or print dpst and lunlow. It's fine. It's fine. We just do that. And the same thing. dpst len high. We probably should indicate, right, what this one is. So this is for low, okay? This is for low, and this is for high, right? This is for high, and this one is in between. Okay, we can just say between. Okay, let's. Oh, hold on, and change the test case. We need test cases. No, 1, 2. 2, 3, 4. Answer is 23. I only get 22. We need to figure out why this is the case. Okay, so we start with 1, 3. I think that's the same, right? That's the same. I hope that's the same. So again, here is we go with 2, 3, 4. Okay, 2, 3, 4. So 2, 3, 4 we have, 2, 3, 4 itself, and 2 we can go 1, right? 2 can go 1, 2 we can go 3, and 2, 1 we can go 2, 1, 0, 2, 1, 2, and 2, 3 we can go another one, right? 2, 3, because I can go 4, I can go 2, 3, 2. So that shall be 4. And I only have 3, so that's where we got a problem. I'm missing one of them. Okay, I'm missing one of them. And how about in between? Start. Oh, hi, I have 1 and 3. Okay. Yeah, everything else I think is fine. The problem is I'm missing. This is 3. I should be 4. Okay, so what happened? All right, we go count edge is high. So we start with 2, right? 2 comes in. Current is 2 as well. And then we say the current is equal. So I do, I push 3 in it. I push 3 in it. I push 1 in it. That's it. Okay, next one, I have 3, right? I have 3. Now when I have 3 in it, I will have 3 in it. It's equal again. So I can push 4 or I can push 2, right? I can push 4 or I could push 2. And other one is 1 in it. So 1 with 2, so that should be fine. So now we have 4 and 2 in it for the last one. So the last one, 4 is the same, and then I go for the next one, right? I go for the next one. Handle this, done. And then the next one come out. I should have 4, right? I should have 4. Okay, let's take a look what happened. So I can say, let's do print the current D, right? I want a current what we are dealing with, and the index. No, not the current D. I want, hold on, I want the Q, right? I want to see what is inside. Nah, what is inside? What is inside the Q? And I want to see the count. Just peek into. This I actually should do. If we're at this level, we shall use debugger. Come on, we shall use debugger. We shall also do. I need to also know if it is low. Okay, so I don't handle the low, I handle the fall. How do you? Oh, shoot. I'm calling them twice. Ugh, that's all right. I have to get a false one. Okay, false. I have 2 in it. Current is 0. Then I have 1 and 3 in it. Current is 1. Right, so basically we say 1 and 3, I get 1. And 2 and 4, which is the last. 1 and 3, I get 1. One and 3, I get 1. That's not the best way to do it. I do it here. Then I don't have to do Q. I will do D, and then I will do the count. Okay? Okay. Okay, let's try this one. So false is a 2. Count current is 0 because I push, when it's a 2, I push 1 and 3 in. Now it is a 1. I am missing, I say start from 1. I only get 1. And start from 3, I don't do anything. Now I start with 2, I get a 1. And I start from 4, I don't get anything because start from 2, I'm good. Start 4, I don't get anything, but I get 1 at the end. So that's why I got 3. What I'm missing is either this, the 210 or 212. That's weird. DP, hold on. Let me call DP. Let me do it here. Okay, so we call DP D lineage. Okay, minus index minus 1. All right, let's just take a look. I feel like this is where we have the issue. False. D is 1. D is 1. We get a 1. Why do we get 1? Lineage is 3. Okay. 3 minus index. Index is 1. 3 minus 1. 3 minus 1 is 2. Oh, do you minus 1? What the hell? Are you telling me it should be len edge minus index directly? You're telling me that we should do this? And how does the other things succeed? Hold on, I just want to know the total number of digits starting from D, right? Starting from the current, which is what the index is pointing to, right? Which is index pointing to. Yeah, why do I do -1? It doesn't make any sense, right? Doesn't make any sense. So this one will pass. Let's try this one. Do both pass? Both pass. Huh. All right, let's comment out all the print. Yeah, this is not gonna work. We need to figure out a way not to do all these print statements. This is stupid. As stupid as it can get. Let's go up 37. Okay. All right, let's give it one more shot. Give this one more shot. This one shall be right. Okay, how about we do 1, 2, 3, 4? Come on. All right. That looks promising. And for 5, 6, 7, 8, 9, 0. How about this? Ugh. Man. Okay, what is the problem? Ending at 0? Is that the problem? How about A9, A90? Okay, A90. Yep. All right, we have a new thing to worry about. Okay, so we're gonna do comment out these two. We have 1, 2, and 890. Something with the, answer should be 45. Oh man, I have to recommend. Oh. And the thing is, I don't know which part is actually having this issue, right? Which part? You know what? Let me not do this yet. Let me just take a look at this. Okay, again, A90. I think the problem is with A90 because we're only one off, right? If we are one off, most likely is A90 is the problem. So if we have A90, do we have 3? 890. So first is 8. Second value can be 9 or can be 7. If it's 9, I can do an 8, right? But I cannot go up. 7, I can do an 8 or 876. But this cannot do, which means I shall only have 2. You are kidding me, man. You are kidding me. You are absolutely kidding me. So that means we still have error here. Okay, so we start from 8. Okay, and we next one pushes 9 or 7. Okay, now we go to 9. The next one we can push is 8. Because it's larger equal to 0, we push 8, but this is not, so we only push 8. Okay, we push 8. And then the next one comes. Current is 0. And D is not low, and then D is smaller than this. No, D is low, so I don't count this. All right, I have no clue. So let's take a look. So false 7272. Okay, so for 7 I got 2. Oh, that's when we get out. Oh, Lord. That's when we get out. That's when we get out. So when we get out, yeah, we shouldn't count. We should not count. Should be, this is at the end, and probably say and queue. There's still something in the queue, right? There's still something in the queue. Then we, yeah, if there's still something in the queue, but what if there are multiple things? There shouldn't be multiple things in the queue, right? In this case, there should be nothing in the queue. We did go through everything, but there's nothing in the queue, right? There's nothing in the queue. And if there's nothing in the queue, it shouldn't plus equal to queue. Maybe I should just say plus equal to length of queue. What do you think about that? Length of queue. And the whole purpose of this is we keep going, we keep going, we keep going. If any value is good, we would have counted already. It's only when the value is not good, then, I mean, I think this will work. Ugh! What the hell? This doesn't work. And become 44. It becomes 0. Oh. Oh, this is hurt. This is a hurt. Oh my god, this is a hurt. How? Because 1, 2, I have 1, I have 2, and nothing gets pushed in. Then at the end, the queue is empty. Ugh. Okay, how do I reconcile these two conditions? How do I reconcile these two conditions? What if we just add stuff? You know, that means it's good. But in the other case, it's not good. So maybe, what if we just add stuff? We just do that. What do you think? Okay. And I think it's possible. All right, let's go one more shot. If this time still doesn't work, we'll call it a day for today and then do the debugging tomorrow. Oh my god, sorry, I should comment out all these things. Comment out this, comment out this, comment this, comment this, and comment this. Okay. So we'll do 1, 2, 3. We actually can have Control Z, Control Z, Control Z. Yeah, this one. This is the ultimate test. Ooh wee! So far looking good. The random number test. Okay. Try this one. I have a, oh my goodness, my bad. Yes, all right, looks promising. Dude, this one looks promising. Now the only fear is it will time out, but I have some faith in this. 走你 Come on. Come on. Ugh. Huh. That is very weird. We failed a very simple That's such a simple test case and we fail. Okay. That's alright. How many have we passed? We passed quite a few. Something is seriously wrong here. Something is seriously wrong here. Okay, so that's what we need to do tomorrow. I don't want to keep doing today. And 26 and 60 should be 6. I got, my god. Ugh. 2, 6 is 0. 6, 0 is 0. Okay, yeah, both are 0. So we start from 3. Oh, I see. Damn. Damn. Okay. So it's the problem is here. I cannot go. Oh my god. It's depending on the high. They are the Okay. So if they have the same number of digits, right? If they have the same number of digits, Jesus, the same number of digits, that means we cannot go to the end, which also means that I handled start the edge case here and here, and we shall have a different condition, which is, okay, if len low, right, is equal to len high. Okay, so that is a different condition, so we have to consider it differently. And else, right, and then this is gonna be on the else. Else we can do that, but if they're the same, right, they're the same, then we'll go if it's smaller than 9, yes. Well, it's going to be, if it's smaller than 9 and high. Ugh, how do we handle this? Think we'll do this. Let's yank this. Okay, we say if it's smaller than 9, perfect. Then we're gonna go from this all the way to int high 0, right? But we cannot take that because we already handled it already. So we take high 0, but don't reach it, right? And then from area 1, I add this. Okay. So if we do that, this one's correct. Okay, so 6J. All right, this is our last shot for today. Last shot of today. Let me remove all the prints. This is the print. And this is the print. Print. Okay, we do this. I'll run the other one as well. Oh, the other one will always be correct. Let's do 9. Like that. Ugh. And if you think about it, it does make sense, right? Because if they're the same, holy crap. Holy crap. All right, this is the most difficult part, is if the two are the same. If the two are the same, I think I need to handle it differently. If the two are the same, I need to handle them differently. All right, anyway, I'll deal with this tomorrow. Oof. All right, I'll see you guys tomorrow.